Well, hello there. Welcome to this NetCom2 tutorial. My name is Tom Cook. I'm German and sorry for my accent. Well, let's start off by let me show you the simple dependencies I've already added in my pom.xml. I'm using Maven to include NetCom2. The basic dependency is just this little tag right here. The current version is 0.3. We could also use latest, but well, yeah. And you can also find this in the project site on GitHub, which I'm going to link in the description. Further, I've just used the Maven compiler plugin to get me the source easily, the source compatibility with Java 1.8. To clarify, NetCom2 is meant for Java 1.8. It's compatible with Java 9, but it's meant for 1.8. Further, I've created 3 classes in here. I've created the test object class, the server main, and the client main. The client and server main have a main method to start the program and an empty constructor. And this client start or server start attribute inside the class. I'm just doing this so I do not have to use static to just avoid the static method. There's nothing fancy about it. Now, after you've compiled the pom.xml, the Maven project, you can use NetCom2 to see if it's included correctly. You can just include the client start or server start class. If it includes, you're done. What I'm going to show today is a basic example of how to use those two, and I'm going to simulate that someone is passing the port for the server or the address and the port for the client with the arguments. I'm doing that by simply providing a variable right here. I'm going to set the port at 4444. I'm doing the same at the client. At the client main method. Further, this client needs the address of the server, which is going to be localhost. I'm just going to provide this basic right here. This basically right here. So at the client constructor, we want to receive the address where the server, I can't type, where the server sits and the port at which the server is listening. And that the client, at the server, sorry, we just want to have the port where the server should be running. Now we pass it along here and inside the constructor. Address port, and we are basically set and done to start off this little example. Now let me get a sip of coffee. To create the client start or the server start is pretty simple. I will show it at the server and client. We create the server start attribute as by calling the server start interface and specifically the add method. The server start interface .add method will have the port, so the server will be started at this port, will created at this port, and the client start can be called similar, just client start.add. But as you saw right there, it wants to have the address of the server and the port the server is listening to. Please note that this port for the client start and the server start should be equal, so they connect to each other. Well, that should be basic knowledge, but just to be sure that there are no further problems. And to show off this little example today, I'm going to do everything inside the constructor. Which is not beautiful at all, but I just want to show it off and I do not want to make it more complicated. Now, at the server, to start the server, we have to do basically 2 things. First off, we have to tell the server start to launch. Well, yeah, and this can throw an exception, which I'm going to explain in a second. The second thing we have to do at the server side is to tell the server to accept all next clients. We also could say, well, only accept the next client, which will only block until one client connects. I'm going to use accept all next clients, which will block until we stop the server start or a problem with the connection is encountered. Again, this can throw an exception. Let me collapse those. Alright, those exceptions indicate problems. The start failed exception from the launch method will be thrown if something like another service is running at the port and the server can't occupy the port. This will lead to a start failed exception at the launch method. If this exception is not thrown and this method is completed, we now have reserved the port for the server start. Further, with accepting all next clients, we call in a while loop, to be set easy, accept next client, and a client connection failed exception can be thrown. This is just IO exception stuff and it shouldn't really happen at all. And only it should never happen, to be clear, but it could happen. How you handle those is if the launch fails, you normally would tell the starter of the server, hey, listen, I can't start the server. And with accept all next clients, you would try to accept the next client, regardless of the client connection failed exception. The client start looks familiar. We just say the client start to launch. No, I did not want to do that. With the launch, the client start tries to connect to the server running at the specified address at the specified port. If no server runs, we will encounter a start failed exception, which basically says, hey, listen, there's no server, you should do something about it. Those two now should run. If we start the server and just let the server start, it should not terminate. It should just run. As we see, it runs with the little green dot at the bottom here. We do not encounter anything. We do not see any output. The same should go now for the client main. Great. And note that I started first the server, then the client. If I were to terminate the server, thus process finished, and restart the client, we would see an exception in the client terminating, indicated by not having a green little dot down here. And yeah, connection refused, so not a server running. Great, now we basically connected. To see a little bit more, I'm going to state something here, which you can just take as I say it. I'm going to set the logging to trace at both, so you can see that something is happening there. Let me start the server. Now we should see a little bit more output. Yep. And we should see the client also a little bit output. Great. So with this this NetCom logging mechanism, I'm going to explain in a later video. For now, just to take it that it will produce more output if we do this. The next thing we are going to do inside the server start is we're going to specify how to react to objects. Now, what we want to do in this example is create an echo server. What does an echo server do? It pings objects back to the client that it received it from. How do we do this? Well, first off, we have to get the communication registration. This is basically a container which knows everything that you want to specify for. For example, if you want to send this test object, we should have to get the communication registration and register the test object from class. as an object that could be received. This register method will give us an receive pipeline. This receive pipeline is based upon the pipeline pattern and will just pass through the object that is received. Well, it will pass through multiple stuff, and this is what I'm going to do. I'm going to show now. The at first method is we add something to the head. I just nearly spilled my coffee, just nearly. It's just going to add something to the head, and we have multiple options right now. We could either say I'm just going to have the object that is received, so it's the test object, which, well, yeah, for some parts will just be enough. We could also say, well, I want the session and the object. Well, the session is something that is handled in the background, and you can access this session as you state this right here. The session object contains some useful, or well, just useful methods that you can use. For example, you have the send method, which is basically the method that we are going to use today. Other methods will be explained in a later video detailing the session object. The third thing we could do is let it inject something else. The connection. The connection is a bit more complicated. It's basically a socket connection, a real connection based on a socket. We just need this little statement right here for our echo server example. And I'm going to do it with a method reference. If you do not know what method references is, you can write stuff like where the left and the right part are nearly identical with just let me show you. Everything we do with this object in this session is we tell the session to send the object. It is nearly the same, so we can replace it with the method reference that the session we have given, we just send the object. It's a bit shorter. If you do not know, just Google it, you will find multiple answers to this. Now, at the client main, we will do something similar. Let me remove this and remove this, because this would produce a lot of output otherwise. We could do something similar. We get the communication registration and register the test object class. Again, let me add something to the head of the receiving pipeline. Now we just need the object. With just the object, we want to print it. We just want to print this object out. I'm going to write it long right now. This has to go. As you see, again, we could write it as a method reference, which I'm going to do. We just want to print out the test object that we received. Now, what I've done here is I've stated this little registration part after the creation, but before the launch at both main classes. Why did I do this? Well, basically, we could do this at any point after the creation. We could, for example, say, well, if the server runs for 60 minutes, we want to register something else, or we want to clean up some other stuff. I'm doing this before the launch, so that if a client connects at this point where we're here, the client already has this method and can send test objects, and we can handle those, because otherwise it would be sort of, well, a luck game. If the main thread where this will be registered is slower than the accepting of the client thread, and this is for some unknown reason extremely fast, we would not be able to see what happened here, or this would be triggered. Again, I'm doing the same with the client start just so that we know what to do. The next and last thing we have to do is to send something to the server. How do we do this? Well, we call the client start send method, which will return us a class to handle such stuff, and we are going to say we want to send an object to the server, and here we state we just want to send a new test object and tell, well, hello world. Just this little snippet. With this little snippet, well, basically, if we now restart the server, we won't see anything. Hopefully, great. And now if we restart the client, we will see hello world. It looks like just a simple system out example, but what really happens at this point is the client start sends the object to the server receives it in the background, searches for the registration of the test objects, sees the pipeline right here with the session sent at the beginning, at the head, sorry, and executes this, sends it back to the client. I'm sorry, I have a little problem speaking today. Sends it back to the client, where it will be received by the communication registration here, which searches for the registration of the test object, sees the pipeline with the system out and prints it out. Now I'm going to do it 4 times just so we see it and restart the client. We did not modify anything at the server, and we now see that this is executed 4 times. Now in the future I want to explain a bit more in detail what this framework has to offer in sort of synchronization, other sending methods, and go a bit deeper inside the communication registration and logging. In later videos I'm going to explain connection related stuff and maybe serialization and encryption stuff, but we'll have to see how far it goes. Well, all I have to say now is, until then,